It's my pleasure to have Daniel here again. And I just learned today that in 2 days, it's his 7th anniversary of the PhD defense in this room. We had a bit of a misfortune in the timing of the talk 2 days later, and would have been perfect, but as close as it gets. You probably know Daniel from other tech talks about the HSM, and of course from all the love and care he puts into helping you guys getting data in and out of that thing. I think there's few of us who have more contact with users. So I think he actually knows what people are doing with it.
Thanks.
Daniel, the floor is yours.
Yeah. Thanks, Flo. So actually, I think there are a lot of other people also have a lot of user contact at DKRZ. So, but yeah, but not regarding the HSM. So thanks for the introduction. So today I want to talk about searching and optimizing retrievals of data from tape. And actually, so when I wanted to announce this talk, when I talked to Flo about this talk, I wanted actually to split this talk 50-50, one part searching and one part retrieving. But while I prepared this talk, I realized there are so many details and also some background infos which are quite important to tell you. Therefore, actually, it will be mainly retrieving data. And so I prepared some slides on searching, but actually only a few, and probably we will skip them today, and then we just appended to the slide set which you can download. And if there's quite big interest, so if you are interested in more in searching beyond the slides, which will be online, then please write me an email and we will organize another tech talk on searching particularly. So there's a Q&A document. I think, yeah, Flo already copied it in the chat of this Zoom session. So if you have any questions, please write them. So not those here, but those online. Please write your questions into this document, then we can partly answer them now. And if there are too many questions, we'll answer them later on. There are also some colleagues from DKRZ who are active in this pad and will maybe answer already some questions or order some stuff or whatever. So thanks for those colleagues who do that. Then we have quite extensive documentation. The link is here. So it's normal DKRZ documentation page and so on, then subpage. Yeah, there are a lot of info. So if you have questions after this meeting today and they are not in document, you can look them up in documentation, or otherwise write us an email. That's the pointer. There's a pointer to normal support address from DKRZ, of DKRZ. So we have 3 major tools for interacting with the HSM system. One is the SAK. SAK is provided by Stronglink. It's the official commander interface. We have SAK helpers. SAK helpers are developed at DKRZ. And then we have PySAK, which is, let's say, the Python wrapper suite. And today we will use SAK and SAK helpers. And in the examples which I will show, PySAK will not be used. We are planning a major update of PySAK. So in the moment, it's quite old version installed, and we just have a new release available, but we need to test it, and it will take some weeks until we will make it public. But so there will come a new version with a lot more functions. And so if you want to use these SAK and SAK helpers tool, most of you know probably. So they are available as modules and SAK helpers. So 2 days ago we installed a new version. So best would be not to load this SAK helpers version, but particularly this version. So we will set it as default in 2 or 3 weeks. But we now and in future we'll do the way that we will keep the old versions installed as default, announce a new version, wait 2 to 4 weeks, so that you can update your script and then shift the default to the new version. So far with the introduction. So this is actually the basic order in which I will go through this talk today. Actually, so the last part is this file searching. Probably will skip it, but so we start with the general overview, give some basic examples on retrievals, and then have this part on optimizing retrievals. And so it takes some time until we reach this point, this third item. But actually, that's most important part. But for those of you who don't have much experience yet with tape archive, I have this first two points. So, but I hope that all of you keep active until we reach there. So about what are we talking? So we have on the right-hand side the Levante HPC system with the Lastrophi system, and on the other hand side we have this HSM system with the tape archive. And for certain reasons, it's reasonable to copy data from the Lastrophi system to tape. So first to backup data, but also if our work directory is full, then we put data to tape and so free up space on work. Why do we have this tape archive? So we could just buy for the money which costs all. So for all the money which we pay for the HSM system, we could also buy disks and extend Lastre. But if we look at the costs, so euros which we pay per terabyte, it's cheaper for tape storage compared to disk storage. And also the energy consumption is much lower for tape. So this Lastrophi system, for each megabyte storage space, we have actually in reality at least 2 megabytes, and we have a lot of servers running to keep everything working. And so this costs a lot of energy compared to the tape archive, which also consumes energy, but considerably less. But the disadvantage is clearly that getting data from tape takes much longer. So, and then if you look into this tape library in reality, so this is one of our libraries. There you have tapes, which are in a big shelf or many shelves, and we have these tape robots. And if you want to get data from this tape, for example, then this robot comes, takes the tape, brings it to a tape drive, and then can be read and later it's brought back to the shelf. So that's how hardware looks, and the DKRZ particularly, this whole HSM system, there's a software running called StrongLink. You probably heard about it. And StrongLink has a metadata database for metadata. And apart from the tapes, which are here, there's also a cache. And so when a user wants to copy data, the user copies the data actually from the cache to the Lastrophi system. And if data which the user wants to get is not in the cache yet, then the data is copied first from tape to the cache by StrongLink and then copied to the user. And StrongLink actually introduced a new term which we didn't use with the software used before. And actually, StrongLink uses the word recall to denote the copying process from tape to cache. And I will also use this word in my talk, and we have also a specific command for this with our command line tool. So we have SRK retrieve. So here example calls, command line calls. We have SRK retrieve, and SRK retrieve means if the data is in cache, copy it to me. If it's not in cache, copy it from tape to cache and then get it to me. What does SRK retrieve mean? And this SRK recall, it means just copy data from tape to cache. And the use case for this recall might be, for example, I need data tomorrow morning, and I don't want to copy it already now to Lastre because my disk quota is full, or for other reasons I don't want to copy today, but I already want to get it to cache so that I can get it quite quickly tomorrow morning from the HSM system. And so I could start a SRK recall today evening. The data is copied overnight to the cache, and then tomorrow morning I just get it with normal retrieval. And what's also a point that since the system has the one or the other error regarding tape access, it's quite nice thing to split the retrieval into the recall part and the actual retrieval part, so that it's easier to diagnose issues also in your scripts. I've found some slides which I call practice sessions. And so these are slides where I show some examples on the command line. The slides and also some more slides which I won't show here. They will be in the online version later on, so that we can go through these things. I have some example files here. Those are files actually which I archived during postdoc position on which I worked, and which I like to use as example data also for testing data because it's real data, and we maybe experience real issues with it. So, and this data should be, mouse is gone. So, and this data should be, publicly available. So everyone who wants to test exactly the things I'm showing here can test it with this data. So, so I'm now logged in as Levante, at Levante, and I've loaded the SRK modules. And as I said, it would be a good idea to use the most recent SRK helpers release. The order has to be different. So this is sometimes a bit annoying with these different types of modules. We are considering to change this again, but for the moment you have to live with these two different modules. So when now I want to get some files, and just to get an overview, I can use the command SRK list. And I want to see what's in this particular folder and what's actually the status of the files in there. And as I said before, files can be files which are stored on tapes. They can be only on tape or might be also already in the cache. And you see here, if you do the SRK list, you have here a column, the last column of the permission string. This indicates whether files are in cache or not in cache. So if here's a dash, then the files are available in the cache, so you can quite quickly retrieve them. And if here a T is printed here, that means they are only on tape and they have to be copied first from tape. And this means, for example, this first file is index.txt. If I want to get this file, it's in the cache, it will be copied quite quickly. And also a bit larger file, like this nearly 20 gigabyte file, it can be also copied quite quickly, but would retrieve. So SRK retrieve. I can retrieve this file to the local directory, and then we see quite nicely we have progress bar here, and the progress is also updated. So it takes some time for initialization, but after that, at some point it will start. The number here will start to increase. At least it should start to increase at some point. I tried it half an hour ago and it worked. So while this is running, I switched to another tab. So I showed you this list command to check the caching status, but we have also SRK helpers command, which just called is cached. And with this command, I can check a specific file. And check the caching status of this file. And then I will see, okay, this file is cached. And it will also, this command will return different exit codes depending on whether the file is cached or not. So this is a nice command if you have a script and want to check in a script whether a file is cached or not, to check the caching status there. And I can run this command also for a whole folder. Then I have to provide the -r option. And then I will see that takes a bit. And then I will get the information, not all files are cached. That's the basic thing. If I want to get all files which are not cached, then I can provide -v for verbose mode. I will get a list of all files which are not cached, and I will get also a summary line of the number of files which are not cached, and the total number of files which are in this folder. And with -vv, we get a detailed list for each file. In this folder, we get the status if the file is cached or not cached. And so if you use it in script, well, you can imagine how you can use this maybe in scripts. Yeah, and going back to our retrieval from which I started before. So this retrieval is finished now. 100% complete, one file retrieved. 19 gigabyte was copied. And if we would now start the retrieval of a file which is not in the cache, so for example, this file, this is number 4004, that's not in the cache. If I start this retrieval, then we see it looks a bit different. Do you see it in the room? Do you see it or should? Okay. And then we see that this file needs to be recalled first and then it can be retrieved. If we have a mix of files, let's say some are on tape, some are not in the cache, some are in the cache, then the files in cache, they will be already copied here, could be copied here, and the other needed to be recalled. But so you see both here. What's important, so in these examples, I use just file names, but those of you who use searches, all these commands I show here, they all also work with search IDs. But I won't show that those examples. So everything what I showed here, you can see it in the slides later on. As I said, so there's this short retrieve command before, and the recall command, it works quite similar. And so, as I said, this retrieve command, it does recall and retrieve at once. If we could also say, okay, I just want to recall a file, then I could write SLK recall, and this file is already recalled, so maybe another file. And this recall command, it has a similar progress bar as a retrieval, but it just does a recall and not the retrieval. What's quite nice with recall, that when the recall starts, it starts this recall process in the background in strong link, and you could actually kill this recall command here, but the actual recall in the background, it would still run because it's running in strong link. That's a quite nice feature, you could say. So if you run into some issues, we have page known issues in the documentation, and there you might find some known issues and maybe also find a way to go around them, or maybe realize, okay, they cannot go around them, please contact support. And then there's a central SLK log file. So a lot of errors are not printed to the command line, but are only printed to this log file. And this log file is in your user home directory. It's automatically created .slk. And there's this log file. And there you see things like, for example, I started the retrieval here a few minutes ago. There's the retrieval command that was done. And I also get some additional information with which I will about which I will talk later on. And you see so SLK writes everything into this SLK log. SLK help us are more verbose. They write the errors to the command line. So both commands behave a bit differently. Yeah, just to know, so SLK help us errors will not be printed into this. So far with this fact, so here's a log. If you look later into it, what's also important for those who work with this log file. So you have in the first column, we have always the date. Second column of each log entry, you have the time. Then you have the host name. Normally, you will work on Levante. Then we will have the host name of the Levante node on which you're working. And then you have the PID of the process. And as you see, so and if you want to search all log messages which belong to one SLK call, then these messages, they might be distributed over different parts of the log file. But if you have, let's say, the first part of the command and you have the process ID and the host name, you can easily grab for this combination, and then you get all lines which are related to this SLK command. What's also important to know for you in your scripting and what you use PID, this is not the PID of the overall SLK call, but it's a child PID of the SLK call. That's quite important to know. Just if some things don't work in your scripts. Here it's marked. So actually, so if the strong system was running perfectly, this would be actually the end, because we would just say the system, I want to get these files, and the system gets the files for me, and that's it. as those of you who work with stronging realize, so it doesn't work perfectly. There are certain issues particularly when you retrieve data. And here's some disclaimer. So this should not indicate that stronging is really a bad system. So stronging has a lot of nice features and more features than the system before stronging. So more features than HPSS. Also this search feature. And so there are many nice things. And also from the administrative perspective, there are certain advantages for us. Updating the system is much easier. So update HPSS is quite hard, and so it also means new features and security fixes are much harder to install compared to stronging. But stronging is also more complex, and one could start a philosophical discussion if it's a more complex, more feature-rich system, does it always has more bugs and doesn't work so perfectly like a system with a more narrow focus? That's another discussion, but just to say, okay, could end here, but shouldn't say that stronging is really bad. And maybe sometimes it sounds as we are talking bad about stronging, but actually it's also quite nice in some respects. The recall job queue. So you are users, and I'm also a user for the stronging system, and we are on this side, and on the other side there's the tapes, and there's data on the tapes. And I want to have the data, I want to get the data. Now, when I start a recall as a user, I want, for example, 3 files, then so-called recall job is started. And this recall job, it's put into a queue. So this queue, it's not the Slurm queue that I explicitly wrote it here. There was some misunderstanding in the beginning. So it's not the Slurm queue. Stronging has its own queue, its own queuing system. And if you want to get data, then it's job, or however you want to call it, it's put into this queue, and it's somehow processed. And so, for example, these 3 files, they might be stored on 2 tapes, and so the job gets 2 tapes. If there are 2 tape drives empty, it gets them 2 and puts them tape drives, and that's it. And then comes another user, wants to have 5 files, job is started, each job has certain ID. Maybe these files are all on 1 tape, and that's it. And the first user realizes, oh, I need 2 more files, starts the job, and then maybe these files are actually, the mouse is gone again. Maybe on a tape, which is already used by the first job. And then stronging realizes this and does some optimization and says, okay, I've got already this tape in my drive. There's a new job which also wants to have data from this tape. So I get the new data also from the tape. A stupid system could say, okay, I need this tape for this job. After I got the files for the job, I put the tape back. And when I need the tape for the other job, I get it again. And it would take a lot more time for you to get data. But on the other hand, the system has to optimize, in this case, much more stuff, and how it has to decide in some situations. Do I use this tape also for long waiting job or not? So this feature to optimize this recalls from tape also brings some disadvantages, which I will also mention later on. Okay, and there come more and more jobs, and at some points this queue, let's say the queue is full in the sense that there's a certain limit of jobs that can be processed. And when you have a certain number of jobs here, then all additional jobs which come, they will be queued and have to wait until there's a slot free. And then there's one important thing, there comes another user, and his or her job is also queued. The user wants to have 10 files, and some of these files are on tapes, on some tapes we don't know yet, but let's say 1 file is on a tape which is already in a drive. And then there are certain rare conditions under which this queued job might already get this file from the tape. It's quite rare, and it's not always done, but under certain conditions, it might happen. What I want to say, if you have a job which is actually queued, and you suddenly get one of the files and the other files not, then it doesn't mean that there's an issue, but you actually had that luck and that there was one of the tape you needed or what was used by another running job. So just maybe good background info. If you realize, okay, one file is copied directly and the other file needs 5 hours to get. So now I was talking here about job IDs. And where's the mouse? So you maybe see the job IDs. Yeah. Ach, weiter, das ist falsch. Ja, hier ist egal, ich kann auch da anzeigen, dann gibst du ja trotzdem. Ja, das stimmt, das ist zu Recht. Ja, das ist zu Recht. Auf jeden Fall, danke. Danke, Kalle. Genau, ihr habt hier, you have here the job IDs. And now if you, for example, work with Slurm, what most of you probably do, then you know actually if you run as batch, the as batch command, you directly get the Slurm job ID as output. SRK recall doesn't do this, unfortunately, so we have a feature request running for this, but actually it takes a lot of time. So actually the job ID, it's printed to the SRK log file. And so here's a line, so I shortened it a bit. We have this timestamp, the host name, then we have the process ID, and there is the sentence created copy job with ID, boop, and then there's a command also printed. And so accidentally, so this is actual call of this recall, this SRK call, and the job ID, they are two lines below each other. That hasn't to be the case always. But let's say if we start SRK recall and somehow get this process ID, then it's quite simple to automatically get this job ID. But you need to do some tricks here to get this process ID, but in general, you can do it manually, get this job ID and also get it automatically. And if you have this job ID, you can use it and use SRK bus command called job status, use this ID, and you get something like successful. If the job has finished successful, you might get failed, you might get a queued. And if the job is queued, you will also get your position in this queue. That's it. And all states which are available, there's a help page, and there's also a QR code to this help page where this state here described. Okay, and now the thing is, okay, I said there's a queue, and it might be also interested the queue status, and then we have a command which is called SRK help us job queue, and this will print the total number of jobs, the active jobs and the queued jobs. In this case, there was only one job, so there are some more starty than active and queued, so a job might be also paused, but that's actually information, so we want to keep it as short as possible, and normally they are only relevant for use only active and queued jobs, and in most situations, this should be the sum of the other lines. In this case, it wasn't. They want to choose another example, but I forgot to change it. Yeah, and if something like 100 jobs is written here and maybe 90 queued jobs, it's quite hard if you don't have experience with the system to estimate, well, 90 queued jobs, is it good or bad? Is it normal or not? For this purpose, we have something, a flag called format, and then you can add D or details, and then you will get some textual summary. In this case, it will write, so there's no queue, waiting time in the queue is none. If there are 50 jobs in the queue, then there will be an estimate. The estimate for the waiting time is really, really rough. So it strongly depends on what jobs are there and what system status, but just if there's a waiting time given, it's really a rough estimate, but should give a rough estimation. And as I said before, so the recall, it doesn't need to run during the whole process. So the SRK recall, that doesn't need to run. So if you want to start this recall, you can just run SRK recall. In a second window, you look into the log file and have a look whether there's already printed this line. And if this line has been printed, you can kill the recall, SRK recall in the other terminal. Right, and then write down the job ID and the column.
Ask questions between or just the end?
You can also ask me. I have some question slides in between. I can just have a look, but you can also ask now.
The question would be whether I can just recall with an option saying just kill myself right after start.
No, so we have this as a feature request to Strongling, but the process of implementing feature requests is here. It's a bit complicated, and therefore, so we don't have it. Yeah. We are, yeah. For now, we don't have it, and yeah.
Can I also kill the retrieve and then the recall just continues?
Yeah, sure. So actually, the retrieve we have the same as the recall in this respect, and also actually I forget. Yeah, actually, and also if we look into this log file from before, So as I said, we could kill this recall and it would run anyway. And if we look into this log file, there you see also for the retrieve, actually, there was also a copy job started, and this is also, so now the copy job has also its own ID. So from this perspective, it doesn't matter if you start retrieve or recall. It's just the case that in some situations, let's say the retrieval of a file from the cache to the system, it might also fail if there's a high system load, whatever. And for this purpose, I personally prefer to run first recall, wait until everything is in the cache, and then run the retrieval. That's for my personal, that I see the reason of the error better. So actually, here we would be the questions page. Actually, then something else. It shouldn't be fun, but so we're sitting here since 30 minutes now, and so our concentration is dropping already, probably. Michael, and so I would like to ask you, maybe if you wish, you could get up, and we are all sitting at the desk all day, me too, and we're sitting 2 hours in a video conference and we are not moving properly. And so maybe this is a good situation to just get up also for those at home from your desk, and maybe relax your shoulders a bit if you wish. You don't have to, but just as an input. I would be also interested in the end if you like this, if I said this or not. Some people will be annoyed of this. Others might say, oh, it's really great. I wanted to do this for years and I never was mutig genug to do this. And so just as an input for your own personal health. And while we are relaxing our shoulders, maybe some people, if you have other questions, please ask them. Yeah, maybe first in the room, yeah?
A month ago, you sent an email that I have to find out if my data is on 10 tapes.
Yeah, I will talk about that later on. That will be the part after that. So I will give first a bit background, then I will talk about those commands. Yeah.
For byting,
then if you run, the best is to run SLK archive a second time. So maybe we can talk after that. So actually the best way is to run SLK archive a second time and run it, let's say, until it succeeds, let's say. And if you run it another time and you get a failure, then just run it another time. This is a general suggestion. Yeah, and so it actually, if there's a file only half uploaded, then SLK archive will re-upload this file. If it's only half uploaded, there are situations when files are marked as incomplete, and there are also some false flagging. But it's another huge topic, so it would be too long to talk now about it. But so we have some help about it. But yeah, just write me an email afterwards, and then I can give you some more hints. There was a question about, I think it was canceling in the chat about canceling job, this recall jobs. So no, for users, it's not possible to cancel recall jobs. If you realize you submitted a job which might be somewhat problematic, and I will show you some examples later on when they might be problematic, then please write us an email to support@DKRZ, and they will and then we will cancel it in the background. And then there's another question. Was okay. Was another question set? No. Okay. Perfect. So we'll go on, and I added these question slides. Oh yeah, another question.
I just wondering, how often can I send recall jobs for the same file? Although strongly this happening. To just recall a million times the same file,
yeah. So
just optimize it, or
so if you so if you mean really the same file.
Let's say I want to have a.txt from the table.
Yeah.
And for some reason I just
send it again.
Send a million times recall this thing.
Yes.
Theoretically, it should say, well, call everything together, just one job.
Yeah.
Is it fine? Or?
Yeah, so actually it sends only one job. So if you get one file 10,000 times, then then it will realize when you send the command the second time, oh, I've already a recall job for the same file, and it will give you the same job ID back.
Oh, that's nice.
That's quite nice. I actually wanted to check it if it's the same for search ID. So if you ran a search and do SRK recall search ID, then it should do the same, but I'm not totally sure if it really does this. Yeah, but it doesn't work if you, for example, if you recall one file and then recall two files, and one of these two files is one of those, then it doesn't work. So it only works if it's really the same file or the same file list.
You can always recall only one file.
Yeah, actually, yeah. But we didn't test yet actually if the system can cope with, let's say, 1,000 recalls at once. So if you get 1,000 different files, there might be an issue. But I will talk about later on. Yeah,
I have one question.
And then maybe be behind you first. Sorry.
Oh,
How much you want to go?
I'm sorry, yeah, because you was.
Actually, it's along those lines. Like if you submit a job, you want to get say 1,000 files from a particular number, you know that the different files, and you're like, instead of doing it serially, you submit a job. Is there a limit to how much you can submit? Like, you know, if you want 1,000 files, you want to submit 1,000 first. You submit, no, 10 maybe. I'm not sure.
Yeah.
What's a good practice for that?
So I will show some commands later on for this purpose. So there are some certain conditions where you might cause issues, and we have some specific commands to, let's say, order these recalls. And in the normal way, so you can recall a maximum of 500 files with one command. So if you want to get 105, then you will get an error. But it's not always the file number which might cause issues, but some other factors which I will.
Would it also be a similar rule to apply if you want to upload data?
That's different. So when you upload data, you only copy to the cache. So actually, when you upload data, it would be good to stay below 5 terabyte per SRK archive call.
Yes, but if we submit
a file
one go,
this is a file number. It doesn't matter actually. This is a file number, so you can archive, let's say, 1,000 files at once, and it shouldn't be no issue. It's just if the amount of data, the size, if that's too high, then SRK archive will probably fly with a connection error in between.
Submission.
For submission, yeah, but maybe you write me an email, and so we have some 1 or 2 pages in documentation on this topic. I can also send you some additional infos on this.
So what is the size of this cache?
2.5 petabyte. And it's for writing and for reading. So it means also if a lot of users archived a lot of data, then it might be on a high fill state. Yeah, but the colleagues from the system department, they care for that somehow always space available.
What is the policy or something for these files is like for example, if something is coming beyond this 2.5, then the one which was the oldest, that will disappear.
Can you repeat the questions before?
Oh yeah, sorry. Okay, so yeah, so in micro. Oh, sorry. Yeah, so there's a question mark for the audience online. What's the rule how old files are deleted in the cache? So that's actually it's based. It's not so. So from a certain time intervals, there's a cleaning job run, and this will delete old files. And old files is in the sense that actually it should remove the files which are already the longest time in the cache, but it doesn't already happen because a certain timestamp cannot be queried properly. And this means that under rare conditions, it might happen that you recall a file and it's deleted 5 minutes later. It shouldn't happen, but if you have really a bad timing, and I know one user on Easter, he had this bad timing, he did a bad recall. Before lunch, he went to lunch and then he came back and this file was already deleted. This might happen, but actually it's quite rare that it happens. More questions? Okay, so for those of you at home who are still doing this, you can stop now, you can also proceed. It's your health. So yeah, again, it's your health. So just as an input. And I would be really, really, really interested on honest feedback. If you didn't like it, please write me. And if you liked it, please also write me. So, and I said, so we have this limit, only a certain number of recall jobs can run in parallel, and above this limit, there's they can run nothing. And as we know from Slurm, normally it's the way if there's a node free, Levante node, and I want to use one node, then often I get it. If there's, let's say, there are certain policies when nodes are kept free, but actually, if their resources free, they should not be used by a bigger job than they are taken normally. But with Strong, it's a bit different. First, I have to say, to talk about a bit why do we have this limitation? So we have only limited number of tape drives, and we can only get read data from as much tapes as we have tape drives. But then we have also some other boundary conditions. So we have 3 different generations of tapes, let's say old ones, not so old ones, and new ones, and also tape drives of these generations. And if we have a tape of type A, then it can be only read by tape drives of tape A. And this also means if all of you want to get data from tapes of type A, then not all tape drives are available for this purpose, but only, let's say, 10 or 20 of this particular type. This limits somehow the capability of the system. And also we have different tape libraries. And maybe you have read it, we have also new libraries. And if you want to get data from a tape in a new library, and all tape drives in this new library are currently in use, but they're tape drives free in an old library, then this tape in this new library cannot be read because, so there might be still free drives, but cannot be read because it's the wrong library. And what one might think, okay, we could do some dynamic job limiting, so that always, if there's a tape, if the tape from which I need data has a tape drive available, then this data is gotten directly. And one could also consider, okay, even if I'm in the queue on the 100th position, but I'm the only one who needs tape from type A, and all other users from type B, that maybe I get to the front and my data is copied. That's not the case in Strong. One could do this, but we saw already Strong does a lot of optimization, and each optimization step we add might cause also new bugs. And therefore they said, okay, in this case, we have this static limit. For example, 14, 20 jobs can run in parallel, and every job else is queued, even if the job could be processed. And one thing which might irritate somebody, and there might be also another situation, I'm mentioning this is just one example here. Let's assume we can process maybe 4 jobs in parallel, and we have 6 tape drives. These red things are tape drives. Oops. And the first 3 jobs, they already use up all the tape drives with their tapes. And then there comes the 4th job, which is actually in processing state, but in reality, there's no tape drive left for his or her own job. So this job has to wait. So if you query the job status of this job, you will get information it's processing, because it's a processing area and it's not officially queued, but in reality, it is in the state in between. So it's still waiting to get a tape drive. And this also means for you, if you, let's say, if you're a bit irritated that the job of you is in processing state for a long time, there might be this situation that you want to get that the library in which the tape is, which you need, that this library is accidentally quite busy. There's no tape drive available. Might be a situation. Just, if you have long waiting times, which you don't understand. But also if you wait 5 hours and job is processing and really nothing happens, write us an email to support at DKRZ and we have a more detailed look, also colleagues from the administration. Do we have questions? Online maybe? In the chat? Okay.
Yeah, can the user know like which if his data is on different tapes or?
I will show a command later on. And probably it's already on. I don't know if it's on the next slide. Okay, so it's not on the next slide, but I will first introduce a problem, and then give a command fitting to a question, also to the other questions which were asked before. So let's assume I'm a user and I want to have 120 files and these files are on 50 tapes. So in the moment as a user, you don't know yet that these files are on 50 tapes, but you know you want to have 120 files. Example might be I have 10 years of simulation, I have monthly output files, and I want to have, let's say, this 10 years of simulation, 12 months each year, so 120 files, and they are 50 tapes, and submit this, and the system takes one tape, another tape, and 48 tapes in between. And then there comes another user and wants 90 files, and the files are on n+2 other tapes, and also on one of the tapes of my 50 tapes. And then the first user realizes, or I realize, oh, I need 120 more files. So a situation might be I have one file per variable, and I want to have temperature, and first I do the recall for the temperature here, and then later on I do the recall for the precipitation, whatever. And then there is a high probability that, well, I archive these files probably at the same time. At least January 2022 was temperature and precipitation was probably archived at the same time. It's a high probability that these files are on the same tape. And this means there will be a probably large intersection between this recall job and this recall job with respect to the tapes. But there will be also maybe other tapes. And in this situation, stronging becomes really, really slow. So situation just, let me repeat it. So we have 2 or 3 users. They want to have many files. They are on many tapes. And there's a certain intersection between the tapes. And what stronging does in the background is it tries to optimize the tape access and tries to put together which tape I should use and for which job I should get files. And this optimization process somehow uses a lot of system performance and uses more and more and more. And the system becomes really, really slow, with the result that these jobs are actually not processed at all anymore, or only with 10% of the speed or only 1% of the speed. And all other jobs which come after that, they have to wait, and they are queued, and the queue is growing much more. And some of you who tried to get data around Easter this year, they realize this. So this is actually a plot on the y-axis. You have the number of recall jobs in the system, and this is the time axis. And here you see, so you have 0, 50, 100. Normal situation is we have maybe 10 to 20 jobs in the system at all, but suddenly we're at here more than 100 jobs. And the green ones, these are the running jobs. The other ones are the queue jobs, and this is 14. This was processing limit at that time. And so what happened here? So the situation was not that just so many users want to have the data, but that we have a few bad jobs with this configuration. Actually, we didn't know before that this isn't issue, but then suddenly we realized, okay, something is really bad. And some users waited 2 days for the data because it didn't resolve. The system was under high load. We didn't know what the reason was. And then after some diagnosis, strong developers or colleagues from system department, I'm not sure who, actually found out what the actual reason was. And so this is quite bad when this happens. But actually you don't know this, or until today you didn't know this. And therefore I'm talking today. So the main reason why I give this talk today is that to inform you about the general procedure, but also particularly about this issue. And it's quite easy for one user to cause this behavior, to do this type of recall, 10 years, whatever data I want, to cause this. And this affects all users then. The colleagues from the system department, DKRZ, they know this behavior now, and they are monitoring the recall queue for those jobs. So probably this will not happen again, at least not during the week, because the colleagues, they look at the queue, and if the queue gets a certain length, they look in detail if there's a job which might cause this and kills this job. Yeah.
How do I get my 10 years of data then?
I'll show you afterwards. But that's first, yeah. So I will show you the command. If you have questions, just write me an email after that. But yeah, we have some commands for you here. And also saying this, so there's, let's say we see this job queue and we see which files are retrieved or recalled, but we don't see who did it. So there's some data protection in this. So we see that there's a job and this job might cause issues, so we kill it, but we don't know whom it belongs. and we cannot notify the user. Most time we can notify user because we see the files, see the owner, and then we write to the owner of the files. But there are certain data pools which many users use, and then we don't know it. Therefore, if you get data and run a job for 120 files and gets killed and try it again and dies for unknown reason, then maybe write an email to support at DKRZ and ask us. In general, if it fails, often just write us an email. Yeah?
The whole thing is if you have like many files in one job, why does the strong link system allow this at all? Or does it just create one job?
It's, let's say, this optimization thing. So the best way would be to create one job per tape. Maybe let's say if you would create one job per file, then this then let's say it might happen that the tape is ejected and inserted often again and again. So because if I would split up this year into 240 individual retrievals, then the strong system, the one solution would be to just get one tape for one file, get the file, put the tape out, and so on.
You said before that it will automatically pull the jobs together, which
right, and that's actually the issue here. That this pooling algorithm, the pooling algorithm has a bug, and there's actually the pooling of requests of many requests for one tape. This pooling algorithm has somehow a bug, and that's the actual issue here. So even if right, so yeah. And this and the strong people, they know about it, and therefore they have a certain upper limit here in the queue where they really say, okay, we don't do this optimization. So normally they do this optimization only for those jobs which are in processing state, and then they know it works properly. And they said they also had this implemented that for the whole queue they use this optimization. But then the system gets slow again and something doesn't work properly. And therefore, for you as a user, if you really split, if you do a recall for each file individually, you can do this. It will not overload the system. Probably it will not overload the system, but it will be very, very slow because it might mean that if there are 5 of your files on one tape, and these 5 jobs for these files are apart from each other, that they are processed individually, and that the same tape is taken 5 times. Yeah, in theory, you could optimize it and do some stuff. In theory, I'm completely with you, but in practice, it's so it doesn't work somehow.
And so now the idea is that users should implement the algorithm correctly instead of strongly?
No, not directly. I will show you a command after that. So there are 2 approaches. So the simple approach would be, let's say, and we don't do this, but if you wish, you can do this, and it's not something we do this in the moment. So we run one recall for each file we want to have. And this will probably not cause a slow system. It will cause many recall jobs. So if I need 1,000 files and send 1,000 jobs, it's quite a lot. And if 5 users use it, it will be quite a lot. And we are not sure if the system can cope with 5,000 jobs. So we didn't actually test that during our testing phase because we didn't expect it. But you will use the synergetical effects of, let's say, multiple files on one tape, and this tape is only read once. That's it. Let's say the brute force approach to not overload the system. A better approach would be to look, well, I want to have 500 files. I look which files are on one tape, and I will run a recall for each tape individually, or maybe for 2 tapes together. That would be most efficient, so that I do some optimization in before and send some good pieces to the strong system. And this would look this way. So again, the same example as before, but now we have the splitting, and the user says, okay, I know 9 files on 2 tapes, and I do this recall, then I do another recall. Let's say I always split it for 2 tapes, and then 4 files on 2 tapes, and they are taken, and then the other one, and then it might be fair for other users to say, okay, now I wait 10 minutes, so other users can also come and get their files from tapes. And if there's then some intersection, then it will be hopefully also combined well, depending on the queue length. And then after 5 minutes, I start again to get more files and so on and so on. So in this way, the strong system remains quite fast and stable for everyone. I know it sounds quite complicated, and you're asking yourself, okay, how do I get this tape info? That's a big question. Yeah.
Yeah, that's my question. Now we expected to know where the files on which tapes they are.
Yeah, right. So yeah, right. Just to see the command afterwards. Other question? You also no. Yeah.
This is exactly the element which the storage system is supposed to do.
Yeah, right.
So,
yeah.
And they are, for some reason, don't manage to implement it correctly. So now all users of the system should individually implement the algorithm correctly themselves.
Yes, the point is they are doing some optimization in the background, but something it's going wrong. But it only happens if many tapes are needed. So yeah. Yeah, that's the point. Yeah, that's the point. Yeah, but we don't know, and they know of this issue, but they don't find it. So maybe they use an external library for this, and this library gets this thing. The library is buggy. We don't know actually, but they know of this issue, and they didn't find the cause for this yet. Yeah. Yeah, you're right. Yeah, the point is what I said at the beginning about. So we are talking quite bad about stronging, but the situation only appears because stronging it's quite nice to get many files at once. With HPSS, it was much harder to get, let's say, this file pattern. For example, I have 10 years of data, monthly output files, and these files are in different folders. Let's say I have 10 folders for 10 years. And in each folder, there are 100 files for 100 variables. And I only want to get, let's say, 2 files from each folder. With HPS, no, 2 files, 24 files from each folder. And with HPSS, it wouldn't have been possible to do this at once. You needed to do many individual recalls. And if you would do this with strong-link, then it would run quite nicely. But since you can do a search in strong-link and search for these files with regular expressions and so on, it works. So maybe HPSS would have had the same issue as strong-link, but we didn't realize because it didn't have the feature to search for the files at once.
What's the problem in sending 10,000 files or just 10,000 jobs?
We don't know. Yeah, we don't know. We don't know. So, I don't know. It doesn't work. That's it. Yeah.
One file is of several tapes.
It might be so. Let's say for the old tape generations, there's the tapes were considerably smaller than today, and there are situations that files which were archived with HPSS, they are sometimes split onto 2 tapes if they were too large. All files that were archived with strong-link so far, they are only on 1 tape because they do not extend beyond the size of a tape.
When was this cutoff between HPSS and strong-link?
You mean the size cutoff? You mean the change?
Yeah.
November 2021.
So anything that we archived before that, you mean the HPSS system that got transferred, and so we don't know if it might be split into different tapes? Yeah. So let's say
yeah, but let's say if you archive data, the last 2 years of HPSS, it's probably on tapes which are sufficient large that it's not split. So you cannot really say the strong HPSS difference. There are also situations in the beginning, we did a background migration of HPSS data to, let's say, a new format which strong uses. And so some files that were split on HPSS tapes and which were migrated in the background in the past, they might be already on 1 tape now. So it's, cannot definitely say this, but the command I will show it already also print information on this.
Depending on the file size, right?
File size, yeah. File size and type generation.
If you had terabyte files, you may have a problem.
Yeah, so if you
stay below 500 gigs, that should be okay.
Yeah, right. Yeah, something like that. Yeah. Okay, so we have already 1 hour gone. So as you already realized, so it puts a lot of work effort to you. That's the point, but that's the situation as it is. And at the same time, strong-link has some nice features like the search feature, which HPSS didn't have. So as said, it also has nice things. So now we are in a quite maybe in a bad situation. You think, oh God, what I should do? So I want to have 360 files. They are on 71 tapes, and somehow I need to plan the retrievals from these tapes. And the retrievals, they might also fail or take a long time. And also, I didn't mention this, but if so, a tape, it might be blocked for reading. So let's say if data is written onto a tape and I want to get data from this, so I've got a tape here, and there's currently data written onto this tape, then we cannot read from this tape because this tape, it's one magnetic band. It's one magnetic tape and it can be only read at one position. So if someone is currently writing to this, then reading is not possible and then this tape is blocked for you. And also this recall jobs, they might fail for different reasons, whatever. So it's good luck doing this. And I talked a lot and it was a lot of information. Maybe it's a good situation just to maybe relax again before I go to the next slides, because it's really much. So we are talking about an hour already now. And right. Just to maybe also, if you're at home, maybe open the window, get fresh air and into the room, whatever. We have also, that's quite nice. We have the CO2 ample, traffic lights for CO2. It's quite nice. And other questions in the audience or online, other online questions? I have a brief look into our online questions sheet.
Only answered once.
Okay, perfect. Great. So thanks to the colleagues who are there in the background for doing this. And now we will proceed with talk. So yeah, there were questions. So what do I do now? So I told you there are some issues, and so we have a command. It's called group files by tape. That's quite long. We have a short version, GFBT. Actually, we are also planning, but we're not sure yet. This problem with module system only want actually to make this SLKH, so that you can just tape SLKH space GFBT, so to just work a bit quicker. What's this tool? It can do a lot of things, so it's quite big. So the first thing is what I can do. I can count tapes, number of tapes, and I will. And this is again the practice session slide. So I will go to my terminal and use this command SLK help us GFBT count files. Then I provide a folder. And in this case, I have to type -AR because it should do a recursive for this folder. And this command, it takes some time because it performs a lot of searches in the background. And first, so let's say the basic way I run it, I just get information. So this is really the basic information, very basic thing. I get information. There's 10 files are in the cached, and there are files on different tapes, but I don't get any more infos here. So therefore, it's quite reasonable to run it with details. Actually, so this is historically grown, this command. And for backward compatibility, it remains this way also. This is not really nice. I really suggest to run it directly with these details, because then I see the tape barcode. That's actually, again, some information you shouldn't see as a user, but which might be useful in certain situations. Therefore, it's printed here. And you also see available here and available. So there could be also written blocked. And if there's written blocked for a certain tape, then I would know, okay, this tape is blocked for writing, and maybe I should check in an hour again or 3 hours again.
What is blocking, but what's the problem? So I would assume that if I want to read data from such a tape and it is in use, which should be the case,
yeah,
then my job will likely just queue and I'll get it an hour later.
Yeah, you should assume that.
Okay.
Okay, so.
What is that available? It's available for reading, or it is?
Yeah, available for reading. So there are three, actually there are 4 states. So available, then blocked. Blocked means it's blocked, someone is writing to it and it's system is writing to it and you just have to wait. And then it might be also error state. If you read error, then please write us an email. So probably the colleagues from the administration, they already saw this error, so there's some tape error in the background. But to make sure, just write us an email also that there's a tape error, and then they'll fix it. But most times they also see it before we see it. And then there's a rare situation. So we had 28 files that were written by HPSS, and which were on no tape. We are not totally sure. Probably the tape was damaged and wasn't cleaned up properly, but there might be a rare situation where another fourth tape is here due to an old HPSS error. But actually, we cleaned up all the tapes, informed the users, and there should be no. But just in case there's another state. On the slides to this, what I'm showing here, there's also a link to a list which states are possible.
And the numbers?
The numbers, that's actually the number of files per tape. So on this folder. Oh yeah, right. Yeah. So all from these files in this folder, there are 3 files on this tape. So there are 10 files in cache. If there's a file in cache and also on one of these tapes, then it's not counted here, as far as I remember. So it's only counted once, I think. So it might be also, if the cache is cleaned in 1 hour, then these numbers here, they might also change. So this is the number of files that have to, so from the perspective now, this is the number of files that have been taken from these individual tapes. Yeah.
From that, we can also find now that some files are there in multiple tapes.
Yeah. Oh, yeah, good question. Yeah, that was a question. So if there are files on multiple tapes, then you have a line below here. A line below which indicates, okay, there are multi-tape files and so many multi-tape files. And so we do not list that for each file or each so they are just listed separately. And they can be get in an individual step. But all these files which are counted here, they are only sort of one tape.
No, but some is 10.
Oh no, that's another. Some this is the files which are in the cache. Because the files in the cache, they can be taken directly, and the others they are not in the cache, but only on tapes. Questions online? No. Okay. So, and if we remove this count files, then it takes some time, and let's say the first step, then we get. Actually, you probably don't need it, but just as intermediate step, you see here, you get a list of files per tape, the files on this tape. And just for those of you who want to have some background info, it's quite nice. So in this case, these are, I don't know, roughly 20 to 30 files. If you do this for 1,000 files, it may take longer because actually, in this case, there's one search run, but it might be that when the system flows, it might take a bit longer. So there's also a -v and -vv flags for some. So then some progress information is printed. Just sometimes if you do big queries, it's a good idea to run this with this verbose option, because then you really see if the command is running or if it's somehow hanging. Therefore, it might be a good idea. What's also quite nice with this new SRK release is what I suggested to use, that this diagnostic output at the top, this is written to the standard error stream, and this actually useful output that's written to standard out. So you could pipe the output, the normal output, into a file to process it somehow and just get the diagnostic output to the command line, just as background info. But that's only with the new SRK version. Okay, so again, I have a file list, and I would think, okay, well, I have to put this file together and do searches, a lot of work. And therefore, you have also some flag called full. There are also many more flags, and this full summarizes some more flags. But what this actually does, it's here it's really useful to run it in verbose mode, because it really might take long. It runs in the end a search for each tape, and it will print. So you have some. You can read it later on if you wish. You don't have to read it now. But it runs actually in the background. So we have data on 9 tapes, and it runs 9 search queries. And in the end, which takes some time, it prints you. The mouse is back again. It prints you this number, and these are actually search IDs. And what I can do now, for example, if I want to get all the cached files, I can do SRK retrieve. If you're working on only one to login nodes, you only can retrieve one file at once. So you needed to do something like this alloc with an account of your choice. And you need to get sufficient memory, always 6 GB. That's everything documentation, particularly this with 6 GB of memory. It's mentioned at several locations, and it's really important. Otherwise, your SRK will be probably killed by the system because it uses too much memory. Now it takes some time until this allocation is started. And why this is doing so? So I can log into so I can log into another node to which you don't have access. No. Okay. Oh, then we go back here. Okay, so what we could do now. So for example, we got the search IDs here. And just have to wait. Yeah, there it is. So we could now do SRK retrieve and insert the search ID, for example, for the files already in cache. Copy it into the current folder, and then the retrieval will start. You need to get 142 GB and a tagibit, and then these files will be retrieved. What's important when we retrieve from a search ID is that the whole folder structure is reconstructed. So because it's a search, a search might find files with the same name in different directories, and it would copy all files into one target directory that would be overwritten. And so we have here, I can show it to you here, we get a folder called arg, and the whole folder wiki, and this folder the files are copied to, and all files which have this tilde in the beginning and have this long number and SRK retrieve, they are temporary files which are currently filled, and when a file is fully retrieved, then it will rename to the proper name. And this works quite quick. And what I could do now for each of these search IDs, so this files which are in cache are directly retrieved. Now I could take each of these other search IDs which are generated here, copy it, and do a retrieval of, for example, SRK recall for this. And one procedure would be, for example, I do a recall for each of the search IDs I have in this list. And in the end, I just do a SRK retrieve for the whole folder. Then I get everything. Okay, so in this login node, it doesn't work. Okay, yeah. And the recall command is the same on login nodes. You only can recall one file at once. You have to have this interactive session with salloc or another normal Slurm, non-interactive Slurm job to do this. And here's the retrieval is running. Yeah.
Do you have to automate this for the users?
Yeah.
Or do we actually have to?
Yeah, so let's say we are working on this. So let's say we are working a bit stepwise. So the first step was to have this command to get this properly, to put the tapes together and extend this a bit. And we have as next step we have a wrapper script, which I will show soon as the last part of today's talk, which simplifies this getting back the files. But let's say the target would be to have even simpler approach, but fully automating the whole retrieval with getting the file from tape, it wouldn't be possible, but improving the situation a bit, that's realistic, but I cannot give a time frame for this. So it will be for sure not possible that you, let's say in half a year, say I want to retrieve these 1,000 files and they are properly taken from tape and gotten back. It won't be possible. But we will try to give you means to make it a bit simpler.
I guess the other thing is you show an example for going through the whole folder of it. And then sometimes we save the stuff, we save it all under the routine component, all under the atmospheric folder, put it down until we don't want to download the whole thing.
Yeah.
Does this also have a way in which we say, actually, I only want it from this time range to this time range on this particular style of file output?
Yeah. So let's say I have so we have two things. So maybe so so let's say it's this way. So you can define search queries, and you can run a search based on the search query. So you can define a certain file name pattern in folders and search in them. That would have been, let's say, the second part of today's talk. And there are some commands in the end of this presentation, which I won't show today, or enough to have a detailed look into it. And you can use these commands to generate a search query, which you can then run in the second step. And there are two possibilities. So let's say there's a command called SLK search, and there you can write down where just write the dots here. There you can insert a search query, and when you run the search, you get a search ID. And when you have the search ID, you can use this with out here. You can use this with GFBT, and instead of providing a folder, you can say minus search ID. Then you provide the search ID. It could be, let's say, this one, 1, 2, 3, 4, 5, and then it will do the splitting up for your case. So maybe if we have a bit time in the end, I can show one example for this folder with the search. But that's actually the basic idea. And if you use the search ID, then you can also use the other flags like this minus full and so on. And the other possibility, if you have a search query available, then so let's say you have set up search query, a string for this, and instead of running a search, it would be better to use the flag minus search query and then insert the search query here. This has the advantage that the searches which this command generates one big search and one search per tape later on. And if you provide a search query, it can optimize this individual searches which are run, and that's much more efficient than compared to using the search ID, because if you for different reasons. So it would be the best if you set up a search query anyway to do it to run the commands this way. You're welcome. Right. Going back to the presentation, this is actually what I talked about now. This -v or -vv option, it's really a good idea to run it with this. It puts out a lot of output, and you actually don't need to read everything, but actually at least to see that the command is still running. Because if you have many files or many tapes, it might really take 10 minutes, 20 minutes if you have a bad constellation system, is high load, whatever. And therefore, it's really a good idea to have this, because then you get at least status updates. And in certain situations which might take a long time, this command also sends, let's say, a heartbeat. If you use this -vv option, telling you, okay, I'm still waiting for search results, everything is okay.
Is it really right to have -r and search ID in the same one?
No, that's wrong. You're right. I corrected. Thanks. Okay, so and here's some information. And the tape state here, I said already, so is available here, and you have a list of possible states and documentation. We skip this, so we have 10 minutes left. I just skip this. So there are two more things I want to mention. So in this situation, I wouldn't use SLK retrieve for getting data from tape. As I said before, if there are errors, it's hard to debug. It would be better to do this. Let's say I start a recall job, get the job ID, wait until the job is finished, and then run the retrieval. We have a wrapper script for this purpose. We copied it. So actually, it's available for 3 months now, and I provided it to a few users who needed a lot of data just for testing. And it's still not running perfectly, but in the sense that it runs quite smoothly in most situations. And if you load the SLK module on Levante, it will be available. and it submits automatically Slurm jobs, which actually do this, what is described here. But in a certain situations, if something goes wrong, there's no well error handling yet. And I don't know if I have time to put it, to make it nicer, but actually this workflow is done by this wrapper script. And the nice thing is you just need to run the script once and it does some stuff in the background. Because what I forgot to mention here, so if you have to wait a long time for your files from tape, maybe let's say 8 hours, and you do it just this way with SRK retrieve, then for example, you start a Slurm job, SRK retrieve, and the Slurm job actually idles for 8 hours until the files are back from tape, then it gets them. And so you waste 8 hours of compute time on one node, you block one node, which other users cannot use, and actually for nothing. And therefore, it's a nicer way, also with respect to resources of Levante and other users, to do it this way. Just start the recall, kill it, get the job ID, and just maybe have a Slurm job, which is waiting for 1 hour and just starts, which is in the Slurm queue and is delayed for 1 hour. And this job starts after 1 hour, checks if the recall job is finished. And if not, this Slurm job starts itself again with 1 hour delay, checks in 1 hour again if the strong recall job is finished, if not, and so on, so that there's always some Slurm job in the pipeline and delayed, but no real resources on the HPC node. And when the strong recall job is finished, then the retrieval, then some other Slurm job is submitted to the retrievals. That's the basic idea what could be done. And this is done actually by this script. This has a quite long name. Maybe we make a short version for it, but for now it has a quite long name. It's called SRK wrapper recall await retrieve. And so it describes what it does. It's a wrapper for recall, and after recall it waits and then does the retrieve. So there are other scripts will come which only do recall or just wait or just retrieve. But so it's you can at least know what it does. So and what you have to provide your account. So some computer time account which can submit Slurm jobs. You have to provide a source. I made it actually for search IDs, but you can also provide a source file name or a source folder, then destination folder to which the file should be retrieved later on. And then there's one log file created for this whole command, and all SRK commands and all scripts which are started by this wrapper script, they all write into one log file, and this log file gets the suffix which you provide here. And normally when I use this command, I normally run this, for example, with one project account. I insert the search ID here for the files I want to get, target folder, and then I use also search ID as a suffix for the log file because it's the simplest way. And then, I run this command, for example, some input and put the search ID in the end, and then I get this type of log file. And when you look into this log file, and actually I want to show an example here, but we only have 5 minutes left, therefore we skip this. And there you have some detailed information. You get information, okay, recall was started, recall was successful, the recall is running with this job ID, submitting next Slurm job, which will wait 1 hour. After 1 hour, this checking job will say, okay, I just checked the job status, the job is still running, whatever. So we will get some verbose info here, and also if this command dies, if something goes wrong in between, you will get some nice info there. It's not perfect yet, and it would be nicer to have it differently for you, but this actually is the way, let's say, with available time and resources from our side, this was until now the best way to, let's say, relieve the system and save some work from your shoulders. And what would be also important, if you have now data on 50 tapes, would be also nice not to run all 50 commands at once, because it means that you put 50 jobs into the queue and all other users which come after you have to wait a long time. So if you want to be nice to other users or want other users to be nice to you, it would be nice to somehow start this delayed. What you could do, for example, would be to run this as a batch job and just do something like minus begin now plus 1 hour. So that's the way what I do normally. I just send 5 of them now. So five in the pack is okay. So I send 5 now, and I make it in a script. I generate this in a script that I have the next package of 5 delayed with 30 minutes, and the next with 60 minutes, and so on. And then I send all these commands at once as learn jobs, and then they start automatically with a respective delay. This would be, let's say, the nice thing. It also saves you work, because you just send everything now, and that's it. It's still not perfect. Yeah. Before we come to the questions, it's just a really short summary about what I talked. So when you want to get roughly more than 10 files at once, please check the number of tapes. As I showed before, when you have only 5 files, just go on. When the check indicates that the data is on 5 tapes or less, just get the files that works. If there are more than 5 tapes needed, please use this command I showed to split up and get the search ID. There's also a flag. This is the short version, also a long name of this flag. If you set this to 2, then the search IDs which will come out, there will be also for 2 tapes. So you will get, let's say, maybe if the data is on 10 tapes, you will get 10 rows, but 2 rows have the same search ID. We have limited this to 2 yet until now and have not increased it yet because we are not sure if it's a good idea to increase it. Maybe we increase it in the future. That's it. For the questions, if you have any feedback on this, and since we are running out of time, just send us an email to support@DKRZ right on the questions document. If you wish other tech talks on other topics like archival, searching, whatever, send us also email there and indicate your interest. And would be also nice for our prioritization. And that's it. And searching is no time for today. But for those of you, you will see the slides online. This is command to run search. So you need to insert a search query, and we have 2 commands. This is the old one, and this is a quite new one. This is since the new release this week. And with these 2 commands, you can generate search queries quite easily. This command, gen file query, is that you provide a file list and get a query to get these files. And here you can provide some certain key value conditions, like if you want to retrieve files in a certain size range, let's say all files smaller than a megabyte in a folder, whatever. You do this, but that's a topic for another time.